All right, guys, we're going to be looking at 11.5, which is appropriate measurements, and it begins on page 845. I'd like to start with shout-outs from my 6th period class. All right, the real world link says recycling. The Green Committee had a recycling drive where they collected aluminum cans, plastic bottles, newspapers, and batteries. The weights collected on the first day are shown. So they got 12.2 pounds of aluminum, 11 pounds of plastic, 19.5 pounds of newspapers, and 13 pounds of batteries. And he wants us to find the mean weight collected. So go ahead and pause the video now and find the mean weight collected. You pause the video, do it. Alright, so you should have found that the mean weight collected was 13.925 pounds. Number 2 says if the newspapers are not included, find the mean weight to the nearest hundredth. So we're going to take out the newspapers now because I guess they're kind of thinking that it's kind of one of the outliers. It's a lot larger. The other numbers are in the low teens, and we've got 19, which is a higher number. So let's try this now, finding the mean again without 19.5. Alright, so now number 2, I came up with 12.06 repeating pounds, and I did that by, instead of having to add up all the numbers, I just subtracted 19.5 from that 55.7 total I had gotten before. And then when I divided, you need to make sure that you're only dividing by 3 values since you only are counting 3 values now. So 12.06 pounds is the answer. The next, number 3, says, how does the weight of the newspapers affect the mean? So obviously having that higher weight of newspapers that was much higher than the rest of the numbers that we had been given, it did raise the mean average. So instead of having an average of almost 14 pounds, we really should have thought of it as having an average of only 12 pounds because between the plastic, aluminum, and batteries, that's more of a reasonable average. 13.9 is a higher average than all of the pieces together. Number 4 says, what is the median for the data set? How does the median differ if the newspapers are not included? So we'll go over that. Pause the video now and do that on your own. Alright, so the median setup for the first one is going to be this, and then the other setup is going to be this one. So going over this first one, using 19.5 included, I put them in order from least to greatest, and I'm going to do my tag you're it, or I can do my n+1 divided by 2, but with so few numbers, I don't think it's super necessary. We're not doing quartiles. So I've got 12.2 and 13 as my center numbers. To be able to find the number that's right in between those two, I'm going to add them up and then divide by 2, and that'll give me my average, or sorry, my median. Alright, so the two medians would be 12.6, and then the very last one, the median is very easy. You just tag your it, and then the middle number is 12.2. So we've got one of the medians as 12.6 pounds, and the other one is 12.2 pounds. And so it's asking how does the median differ if the newspapers are not included. It really doesn't change that much. It's just that when it is included, we have a 4th value, meaning that the median falls in between 12.2 and 13. Whereas when we don't have that 4th number, it lands straight on 12.2. So it's not really that big of a deal that the 19.5 is removed, except that it's just another digit, another value that moves where our median would land. Alright, so using mean, median, and mode, the measure, we're going to look for the ones where we would use mean is when the data has no extreme values. So if you have an outlier, you're not going to want to use mean. So if you have any ones that are very small or very high, mean wouldn't be the best value or the best measure that you'd want to use for finding the center of the data. Median would be a good one to use whenever there are extreme values, because as we saw with our last example, it doesn't really change it all that much. And then there's also, whenever there are no big gaps in the middle of the data, it's also a good idea to use the median. So if it's a well spread out set of information, then median would be a good one because the middle value is what we're looking for, and that could be very helpful. The mode would be best used whenever you have a lot of information that's repeated. So if you have a lot of numbers that are repeated, that would be a good indication of the center of the information and the best measure to use. Because why would we not use, if everybody in the class got 100% except for one person who got 0%, why would we add up all the numbers and find that median being like maybe the low 80s or 90s, whenever you'd want to probably say that the average in the class was 100%, except for that one kid, maybe James, who got a 0%. Sometimes one measure is more appropriate than others to use to summarize a data set. So sometimes using the mean would be most appropriate, sometimes using median, sometimes using mode. So example number 1 says the table shows the number of medals won by the U.S. Which measure is the best measure of the center is best to represent the data? Then find the measure of the center. So we're trying to figure out, would we use mean, median, or mode? So in 92, that says that we won 112 medals. In 96, 101. In 2000, 97. 2004, 103. In 2008, we had 110. So what would be the best way to find the measure of the center? Mean, median, or mode? Going back to our little chart here that they've given us, it says that we should use mean whenever the data has no extreme values. And when you look here, we don't have any extreme values. We've got, things that are in the, low hundreds and high 90s. So it's a pretty nice spread. You could have also used, I believe, the median, because there aren't very many big gaps in the middle. It's pretty, nicely spread out. But when we want the most accurate representation of the measure of the center, if we can, we'd go with mean, because that is really the best measure, in my opinion. Whenever we have to choose between mean and mean and median, that would be the best way to go, is to the mean. So since the data has no extreme values or numbers that are repeated, the mean would be the best to represent the data. So they added up all our numbers, 112, 101, 97, 103, 110, and divide that by 5 to find the mean as 104 3/5. So the mean number of medals won the mean number of medals won is 104 3/5 medals. So number 2 says the table shows the water temperature over several days. Which measure of center best represents the data? And then find the measure of the center. So we've got 82, 82, 82, 85, 82, 81, 78. There are no extreme values here. So mean could be a possible, because there's no extreme numbers. There's really, a good amount in the middle. They're really well spread about it. There's no extreme numbers. We could use median, but the one that sticks with us, if you go back and look, is the data that has many repeated numbers. We would use mode, and in this case, we do have many repeated numbers. 4 out of our 7 numbers are the number 82. So really, that is the best way to go, using mode, which is 82 degrees. So if I was asking for the average temperature, 82 would be a good solid answer. So A says the prices of several DVDs are $22.50, $21.95, 25 even, $21.95, $19.95, $21.95, and $21.50. Which measure of center best represents the data? You need to justify your selection. It'd be good to use the reasoning that we have over here on this chart to say why you chose either mean, median, or mode. So go ahead and pause the video now so that you can answer A. All right, here are the answers. Now, it kind of depended which way you wanted to go with it. I would understand if you wanted your median if median was the measure of the center that you wanted to use, and it would be $21.95. Or if you wanted to use the mode, because it represents the many repeated values, which is the $21.95 3 times. I think either one of those would be the best. I mean, definitely using mean would be accurate as well, because there aren't any, let's see, let me go back to see the wording. There are no extreme values, so using mean would also be appropriate. So Actually, I take really any of them, but I think median and mode were the best ones. And if this was a grade, that's the one I would go for. All right, now we're going to be looking at outliers and appropriate measure. So sometimes data set contain outliers. Outliers are deviations from the majority of the data set. The outlier may affect the measures of center. Remember, the outlier is either a number that's much higher than the rest of the data or much lower than the rest of the data. And they had that very precise, times 1.5 situation going on with the quartiles and a really complex way of finding it. But sometimes it's just really obvious, okay? So the table shows average lifespans of some animals. It says identify the outlier in the data. Here's the thing. If they're telling you there's an outlier in the data, then you can identify it. If they say what is the outlier, it might be that there is no outlier, okay? Oh, well, I don't know. Maybe that's what they're actually saying. I'm trying to decide whether or not they want us to... Oh, you know what? Here we go. I should have just kept reading. It says, compared to the other values, 200 is extremely high. Notice that they didn't make us go through that 1.5 situation that we did back in, 11.3. That's not to say that they're not going to make us do it in the future, because if it's kind of close, we might need to do it to be able to figure out whether or not it's an outlier. But when we're talking that this number is more than 2 times the biggest number, that's covering the bases pretty much, okay? So we know that number is much higher, extremely high. They're using the words extremely high. All right, so outlier would be the 200. In example 3, 200 is an outlier. So, here we go. I knew it was going to happen at some point. So here they go. They find the IQR, which of course they didn't show us how they did that, but they figured it out. And they multiplied that times 1.5, which was 60. They found the median, and they added 60 to it. And so they said 130 is the highest number that we should have in our data set for it not to be considered an outlier. Of course, 200 is much higher than that, so 200 is our outlier. Good to know. I told you guys it was going to come back at some point. Look, it came back right away. All right, number 4 says determine how the outlier affects the mean, median, and mode. So we're using the same data set, and we're going to find all of these things, the mean, median, and mode with and without the outlier. So first, with the outlier, we're going to add all our numbers together and divide it by 7, because there's 1, 2, 3, 4, 5, 6, 7. And we get our average mean being 62. Or it says approximately 52. I wonder if they rounded it. Now, the median, we've put them in order from least to greatest and did the tag year it, or the n+1 divided by 2 to find the position. And 35 ended up being the median. The mode is just whichever one was repeated the most often, and 30 is the only one that's repeated at all, so that's our mode. Now, when we're going without the outlier, honestly, after you've added up all these numbers, you can just subtract the 200 from that amount. You don't have to re-add all the numbers. Just make sure, please, that you only divide by 6 now, because now we're only talking about this, and this amount, which is 6 altogether. We're not going to use the value of 200, so we can't divide by 7. Then when we find the median, we're dealing with an even amount of data. So when we do tag year it, we're in the center of 2 numbers. It ends up being 32.5, and the mode is 30. So notice that the mode doesn't change at all. The mode doesn't change at all, because if it's an outlier, it's not showing up the most often, so it doesn't affect the mode at all. Now the median, again, just like in the other example that we looked at, it changed a little bit, but 32.5 and 35, that's not huge. But if you see the mean, the means are drastically different. We have a mean that was 62, which was almost the highest number besides 70, or we had 39, which kind of makes more sense when we've got so many numbers in the 30s, that it would be maybe a number in the 30s as well, or at least close to the 30s. So the mean lifespan decreased by 62 to 39, or 23 years. The median decreased by 2.5 years, and the mode did not change at all. So it's asking us to determine how the outlier affects each of these things. So again, it decreased the mean by 23 years when we removed it. And then we decreased our median by 2.5 years, and the mode did not change. And that's kind of an important thing that you can get used to having to say is mode is not going to change because outlier does not affect it. All right, stop and reflect. If a data set has an outlier, why might you use the median instead of the mean? Well, going back to this example, look at the example. The mean, because we had an outlier, because in our original information we had an outlier, if I'm looking for the average, the center of our data, and I find the mean, I'm going to get 62, and that doesn't really make sense because it's so much higher than the majority of our numbers. But if I take out the outlier, it becomes a more reasonable number. Whereas with median, 35 and 32.5 really aren't that big of difference. So if I'm to find the central and include the outlier in my data, it would be more reasonable to use median as my center, measure of center, rather than mean, because mean is extremely off the mark. But median, it's pretty close. It's not going to be that far off because honestly, all it's doing is dropping off one of the numbers and making, us change where our middle is of our data set. All right, number 5 says, which measure of center best describes the data with and without the outlier? Justify your selection. And so it says the mean was affected the most by the outlier. Absolutely. It went from 62 to 39. 62 is a really unreasonable number. Now the median, am I missing like a picture or something? Oh, this is the lifespan still. They're just still talking about lifespan, sorry. And then the median lifespan changed very little with or without the outlier. So it didn't change very much at all. And so it best describes the data in both cases. The mode does not describe the data very well because there's only 2 repeated numbers. That's not like a lot of repeated numbers. 2 out of, 7? 2 out of 7 isn't like, oh, that's, most of the data. No, it's 2 out of 7. So the mode wouldn't represent the center very well. All right, so let's do B, C, and D. It says the prices of some new athletic shoes are shown in the table. Identify the outlier in the data set. Determine how the outlier affects the mean, median, and mode of the data. And then tell which measure of center best describes the data with and without the outlier. So, this is not a lot of space. You might need a separate piece of paper to be able to work this all out because, we really want to be very clear with it, just like we have on here, with the outlier and without the outlier, your mean, median, mode, mean, median, mode. Okay? So that's what I want to have you do. And then we'll do D as well. All right. Go ahead and pause the video. No one's here to say pause, pause, pause anymore because I let everybody leave school. But pause the video. Pause, 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 pause. Okay. So obviously for B, $78.95 is the outlier of the data. The other pieces of data, we have something in the 30s, we have something in the 40s, we have some things in the 50s, but we skip all the way from the 60s to the high 70s, and that's just not going to work. That would be the outlier of the data. All right, so here's all my stuff. So the first thing I did was for B, I added up with outlier and without outlier. I added up all my all my values and divided by 7 because there are 7 values here. And so that ended up being $52.33, and that's including the outlier of $78.95. Then I found it without the outlier. To do that, all I did was I took the amount of these all added together, which was $36.30, and I subtracted the $78.95 outlier from it, and then divided that amount by 6. So I just saved myself some work of having to re-add all the numbers by subtracting. So then I had $287.35 divided by 6 and end up with $47.89 for the mean without the outlier. So again, notice that with an outlier that's higher, your mean is going to go higher than it really should. And I mean, $52 is almost the amount of the second highest amount, including the outlier. So, and that's not a really good indicator of the center of the data when most of the data is in the 40s and 30s and 50s. So, that's why we want to take out the outlier if we're going to use mean as our measure of center. Then for median, tag year it, or the n+1 divided by 2 and find the position. With the outlier, it was 48.50. Without, it's 48. It's not a big difference because all we're doing is taking away one of the values. It doesn't really affect the median all that much. For the mode, there was no mode. Nothing was repeated, so no mode. Either case, it didn't matter if I took the outlier or not because, again, the outlier is not going to affect the mode ever because it's not one of the numbers that's duplicated, so it's not a repeat number. It doesn't matter. All right, so let's go back. Hold on a second. All right, so D said to tell which measure best describes the data with and without the outlier. So, with the outlier, I would say that median is the best because, again, anytime you have higher balances, the best center would be to use the median. I would say that without the outlier, mean would probably be the best. I usually lean towards mean. I think it's the best because you're going through more effort, of course, adding up all the values. You're taking everything into account and dividing by how many there are instead of just doing tag year it. But median wouldn't be the worst case either because there's not like a big spread in the middle. So median could also be used, but mean is the best one without the outlier because there's not a big spread. Okay, and again, I'm going to do some extra examples. If you'd like to continue watching, you can. If not, then you can stop, and maybe if you want to get a jump start on work, you can. But I'm going to look at page 850, and I'm looking at number 5, and it says find the error. Pillar is determining which measure of center best describes the data set, 12, 18, 16, 44, 15, and 15. Find her mistake and correct it. So, first and foremost, she just dropped the outlier. It didn't tell us to drop the outlier, so I don't think it's really appropriate that she used mean and dropped the outlier to be able to solve the problem. I think that really, unless they say you can drop the outlier, it's not something that you just do. So I actually think that the mistake is that she used mean instead of median. I think median would have been a better center to use, which would include the 44 and its numbers. So hold on just one moment while I go ahead and put these numbers in order from least to greatest. Now, I do see that, another option is to use mode, but mode, the 15s are only 2 out of the 6. 2 out of 6 isn't like, even half, it's definitely not the majority. So I don't think that is the number that we should be using. We should not be using the mode. So median, I'm going to do my tag year it, and I land right here with 15 and 16. I need the number that's in the middle of those two. Of course, you know that the foolproof method is to do 15 plus 16 divided by 2, which would be 31 divided by 2. Or maybe you know that the difference, the number that's directly in between both 15 and 16 would be 15.5. So 15.5 using the median is the more appropriate way to determine the center because of the outlier. She just dropped it. That's not really something you're supposed to do unless it says do it with and without outlier. If you have a number like 44 that's an outlier, you should be using median to find the best center. Okay. Now the next example, it says number 6, justify conclusions. Determine whether the following statement is true or false. If true, explain your reasoning. If false, give a counterexample. Of mean, median, and mode, the median will always be the most affected by outliers. Think about that for a minute. I want you to pause the video and write your answer, and when you come back, we'll talk about it. Hopefully you thought the answer would be false, because it is not the median that's always most affected. Mean is the one that is most affected. The mean is most affected, not affected, affected by outliers. Okay? And, some of the examples just go back to what we've been doing in this section, where every time the mean is drastically different due to the outlier. Now, let me tell you this, because we haven't had an example, and I don't know if the numbers that you're going to do on your own in class will be with this, but if the outlier is actually a smaller number, then that means that your mean will end up being much smaller than it's supposed to be. If it's a higher outlier, like it's extremely higher than the rest of your numbers, then that means that your mean with the outlier would be higher than it should be. Okay, so the mean is adjusted based on what your outlier is, whether it's a very small number, making your mean smaller, or a very high number, making your mean higher. But the answer to this question is false. Mean is the most affected. Always. Is always the most affected. Number 7 says add 3 data values to the following data set so the mean increases by 10 and the median does not change. Ooh, interesting. This is kind of like a puzzle. Go ahead and pause this and see if you can come up with it, and when we come back I'll go over the answer. Alright, so I'm going to try to explain to you how I've been processing this the whole time. So first thing I did was I put them in order from least to greatest, and it's telling me I need to add 3 values. So and then it also says that the median's not going to change. Well, for the median not to change, the median's going to have to stay 32, because I figured out that the median was 32 in the data that I had been given. Well, for it to be able to stay 32 and for me to add 3 numbers, the only thing that can be next to 32 is the number 32. So I already know that that number is going to be 32. That was such amazing detective work, right? Now, to be able to keep that in the middle, though, I have to add 1 to each side. So now that's my 3 altogether. Otherwise, if I even added any number, like the 2 numbers or 3 numbers over here, my shift would change and 32 wouldn't be in the middle anymore. So that's why I decided that I need to have a number next to 32 and 1 on each side so that 32 stays, both of the 32s stay in the middle. Because when I do tag year it, I'm going to have 2 in the middle, and to make it 32, it has to be 32 and 32 so that the median does not change. All right, so from there, I then decided, okay, I need to find out what the mean is right now so that I can increase it by 10. So finding the mean now, I'm going to add up all my numbers that they gave me and then divide by 5, because that's how many values that they gave me to start, and I came up with 32. I knew I was going to have to add 10 to that, just like the directions told me to, so that the mean will be 42 when I'm done. Then, I then knew that to be able to figure out how much I'm missing and how much I need to add to my 160 to be able to make my average 42, I had to set up my 2-step equation. So I set up my chart here, and let me take away, oh, no, it's not going to work if I do it. No, maybe it will. Let's see. Here we go. All right, I knew I had to set up my 2 steps first. My 160 plus the x that I don't know, and the x is not one value. The x is the total of those 3 values altogether. And I knew I had to divide that by 8 because there will be 8 values when I'm done adding 3 to it. And I knew that that needed to end up being 42 as my answer. So now I'm going to do my, my 2-step equation. First I need to get rid of the 8, so I'm going to multiply both sides by 8. And I got x equals, and so then I got 160 plus x equals 336. Now I need to subtract both sides by 160 so that I get x equals, let's see, 176. Again, not one value, but all 3 of them added together will make 176. So now I'm going to go back to the fact that I know that this number has to be 32 so that my median stays 32. So I know one of my values. I actually know one of my values. So I'm going to take that 176 and I'm going to subtract 32. I have 144 left. I know one of my numbers needs to be below 20 and my other number needs to be above 42. So I can kind of separate it appropriately for that. Now, this is where it'll be fuzzy because not everyone's going to have the same answer. You know, one person might say that this number is 20 and this number is 124. Another person might say that this number is 19 and this number is 125. It kind of just depends on what you make one of the numbers, what the other one will be. But the fact will remain that 32 is the one of the numbers, and then you're going to have a number lower or equal to 20 and a number that is its counterpart to add up to 144 that's bigger than 42. Which isn't going to be a problem. Notice that for the mean to change so much by only adding 3 numbers, I'm actually going to have an outlier. One of these numbers is going to be an outlier because it's going to be 124 and up are the options for the other number. So it's definitely going to be an outlier. Otherwise, I mean, I guess I could also put a number in between here and here. And then whatever that number plus this number is makes 144. I can put one here. And whatever this number is plus this number has to be 144. As long as I don't affect my two 32s in the middle. I definitely can only put one on this side and one on this side. And I know just because of the numbers and that we have to add up to 144 that this position is definitely going to be the one that's filled with an outlier. And then here is where we're going to have a number, or here is where we're going to have the other number, or here is where we're going to have the other number. It really all depends. So if I end up saying, okay, I want 31 to be this number, all the way over here, I'm going to have 111. Or sorry, 113. It would be 113 then. So, so definitely still we're talking an outlier in the hundreds. All right, guys, so I know that was a little crazy, and it'd be interesting if you guys are still watching this. If you are, thank you, but I'll stop now. That's enough examples for now. Let me know what you need in school, and I'll see you there. Have a good one. Bye.